So this video is going to go over solving linear inequalities. Um, we've already kind of gone over them, we just haven't really done it because we've been talking about linear equations, so now we're talking about them as inequalities. So our goals are to be able to recognize the similarities between linear equations and inequalities. We also want to be able to solve linear inequalities, and we want to be able to understand solutions to linear inequalities. So let's get started with them. So a linear inequality. So linear inequality is just a statement of truth. Just like an equation is a statement of truth, an inequality is a statement of truth in mathematics. So it's like an equation in that it's a statement of truth. The difference is, though, that instead of both sides being equal to each other, one side is greater than or less than another side. So here's some examples of some inequalities. We have 3x plus 7 is less than 13, which means that 3x plus 7, no matter what, in order for this to be true, whatever we put into here, this x, has to make it so that this side of the statement is less than 13. Same thing over here. We have 3x minus 6 is less than or equal to. This might be a new symbol here. It just means that it's either less than or it's equal to. So we have 3x minus 7 is less than or equal to 3 times the quantity 7 plus 2x, which means that this side over here, the left side, has to be less than the side on the stuff on the right, or it has to be equal to. It can't be greater than. Down here, we have 2 times the quantity x minus 3 is less than 3 times the quantity 2x plus 2. So this is a definitive statement. It's a definitive less than, meaning that this is for sure less than that. And for whatever reason, I don't have a greater than one on here, but that's okay. And we have that 7y minus 4 is less than 6 plus 2y. So all of these are examples of inequalities because one side isn't equal to the other side. This is kind of like an interesting exception, but it's really saying that it can be equal, but it doesn't necessarily have to be equal, which is why it still counts as an inequality. So there's some types of inequalities. What an inequality means depends on its sign. You have the less than sign, the less than or equal to sign, the greater than sign, or the greater than or equal to sign. So what it's telling you is that one side is either less than or equal to, greater than or equal to the other one. When a less than or greater than, so when we have something that's less than or greater than and equal to something, we include the number of the solution. So basically we can say, yes, we can have one side be equal, but we can also include everything that makes it so that it's unequal. I'm going to have you do a quick check here, and I just want to make sure that we can remember our signs in our inequalities. So I want you to identify the sign of each of these expressions. We're either going to have a less than or equal to, greater than or equal to. So pause, take a moment, and try and find the signs. Now we're going to go over solving linear inequalities. So we can solve a linear inequality almost exactly like a linear equation. So there's one interesting little caveat, one difference in here, and that we had to make sure that the signs are staying true. So that means that the statement has to still be a true statement. What usually happens is when we multiply or divide by a negative, and this is when it's going to start messing things up, the sign of that will flip. Well, what does that mean? Here, let's look at this example here. So we have 4 is less than 8. Right now, this is a true statement because 4 is indeed less than 8. Now what's going to happen? Well, we can multiply both sides by a negative number. Let's multiply both sides by negative 3. And as long as we're multiplying it to both sides, it's an okay thing to do. So you have negative 3 times 4, and that's going to give us a negative 12. I'm going to call that less than for now, and I'll explain why that doesn't work. And then we have an 8 times a negative 3, well, that gives us a negative 24. Let's look at this real quick. this is saying that negative 12 is less than negative 24. But if you think of like, would you rather be owing your friends $12 or $24? You'd rather be owing them $12 because that's closer to 0. So that means that this is wrong. Our sign is wrong. Our sign should actually be flipped. So negative 12 is actually greater than negative 24. This makes this a true statement. And that's why we had to flip it whenever we multiply or divide. We want to make sure it stays true. Basically, after you do an operation with a negative, you want to go through and like check, does this statement still make sense? If I were to like go back through it, am I still making sense in the end? If you're not, it means that you probably need to flip a sign. Let's compare these solutions. So we're going to solve an equation, and then we're going to solve an inequality that's almost exactly like the equation. So we have 3x plus 7 is equal to 13. Well, we're going to try and get that 3x by itself. So we're going to subtract 7 from both sides. We get 3x is equal to 6. Now we're going to divide by 3, and we get x is equal to 2. Well, we can do the same step. We can do exactly the same steps for our inequality. So what we're going to do is we're going to subtract 7 from both sides. We'll get 3x is less than 6. And then we're going to divide both sides by 3 because we still want to get x by itself. So what we end up is x is less than 2. You notice that these two have like different meanings. So x is equal to 2, meaning that x is always equal to 2. Whereas this statement is saying that as long as x is less than 2, you can plug it in, and that statement will still be true. So if you were to plug in a 0 here, you'd get 3 times 0, which would be 0. 0 plus 7 is 7. 7 is less than 13, so that's an okay statement. That's true. So this, we have like more answers that we can plug into our solutions, and that's just like kind of a cool little thing about these. So we're going to solve an inequality here, but this time we're going to end up dividing by a negative. So negative 3x plus 7 is less than 13. We'll subtract our 7's. We'll get negative 3x is less than 6. Let's divide by negative 3. And since we're dividing by a negative, we have to make sure that we flip the sign. So we're going to end up with x is greater than negative 2. Right? So remember, because we had to flip that sign, we have to make sure that we flip it in the end, and it will change our answer a little bit, but it won't be too much. It'll still make some sense as we're going through it. Now we're going to solve these inequalities here. There's a lot on here. I'll make sure that you can see where that division line is. So I want you to take a moment, solve these inequalities. Just pause the video, go through, solve them. When you get to something with a negative, it'll be an interesting experience. Just do your best if you need to, because it's a very interesting topic. It's different. I'll just put it that way. It's a different topic, a different idea. What you want to do is, if you can't quite get it from this video or from me, I 100% suggest you go and see other examples on the internet. So try and solve these, pause it, take a track at it, and see what happens. Now we're going to graph some of these solutions. So graphing is nice because we can use it to help make sense of what we're actually seeing. So we can graph solutions of inequalities on number lines or XY plots. For now, we're just going to do it on number lines. And like I said, we use it to help make sense of things. So we're going to use open and closed circles on our number line to help us understand what the solution is actually saying. So a closed circle, like that dot over there, is used to include a solution. So when we want an included solution, you want to think of equals or greater than or equals or less than or equals. We have this open dot, which apparently should be a little bit lower down, but that's okay. We have open circles, meaning that we don't include that number. So it's kind of like a break, or like, I don't know, it's a break in the set. So when we have something like that, we want to think that it's greater than or less than. When we want to graph our solutions, we basically wanting to see what numbers make the statement true. So we're going to highlight or like shade in the numbers that work on the number line. Let's do an example. So we have 3x plus 7 is less than 13, and we found out through that x has to be less than 2 for that to work. So what's going to happen here? Let's plug in our 2. It's going to be less than, it has to be less than, so we cannot include 2. Because if we plug in 2, then we have 6 plus 7 is 13. 13 is equal to 13, so 13 wouldn't be less than, so it wouldn't work. So we're going to put an open circle there. We want everything less than that. So less than means that it's going to be to the left. We're going to shade in everything to the left of that. Color, color, colorful. If you want to test it though, you can plug in 0. 0 is a nice number that we can do right here, just because it's basically you want to plug in any number that's really nice. 0 times 3 is 0, plus 7 is 7. 7 is less than 3, so that's an okay number right there. If you're to try and plug in 3, you get 3 times 3, which is 9. 9 plus 7 is 16. 16 isn't less than 13, so we start breaking things. So for our last quick check, I want you to graph the inequalities. And my hint for this is that they're going to be the same as the last quick check. So you solved these before, so it's a little bit easier. And now I just want you to go through and graph them. This shouldn't be too bad. Just pause the video, take a crack at it, see what happens. They shouldn't be, like I said, they shouldn't be too bad. So have fun with it.